Hello there. Today we'll be doing the submajority vote. You're given a list of integers, nums, where each number represents a vote to a candidate. Return the IDs of the candidate that have greater than n divided by 3 votes in ascending order. And if it's a bonus if we can solve in O of 1 space. Alright, so in example 1, we can see that we have a bunch of numbers in unsorted order, and we select the top 2 vote getters, which is 5 and 6, and both of them have over 40% of the votes. Have 40% of the votes because they're that's not right, but they have over 33% of the votes, both 5 and 6. Well, to do this, one way is to create a counter and take each candidate and check if they're over 33% and add them to a list and send them out. This would be the most basic way. The other way that we can do in O of n time and O of 1 space is to find out the top vote getters and count those candidates and see if they're over 33%, which is 1/3. The reason why this would be O of 1 space and O of n time is because we're going to go through the list 3 times, 2 times for the nums count, and 1 time to find the majority vote getters. So I think what we're going to do first is that we're going to go over the simple solution. Then we're going to go over the little bit more difficult solution, because that way we can get a better sense of the problem. Okay. So simple solution, we're going to do an O of n time and O of n space. So we're going to create a counter. This is a very helpful function in Python. So we're going to for a candidate in the counter. If the counter candidate is greater than the length of nums divided by 33, so that's, and the majority does not append the candidate. And with that, majority dot sort, which is O of 1 time, because we're sorting 2 numbers, and we return the majority. Let's check this out. Let me shrink my camera, and we have accepted solution, and submit. Success. Very fast. All right, so next solution here is that we're going to do O of 1 space and O of n time. So this is going to shrink our O of, we're going to have fewer counters. So the solution is to have fewer counters. Counter A equals count B equals 0. So for candidates in nums, if count A is equal to 0, we're gonna set A and count A to the candidate and 1. If candidate is equal to A, then we're gonna set count A plus equals 1. If count B is equal to 0, B count B is equal to candidate 1. If count candidate is equal to B, candidate count of B plus equals 1. So else, we're going to do a count of A minus equals 1 and count B minus equals 1. So we're just trying to get the majority, the pool of candidates, to we have 3 buckets. We have A, we have B, and then we have the other. So when we fill in more and more items in A and B, we have we fill in the buckets, and if we throw it into the third bucket, we take away from the other two because someone else is getting more votes until the point where the one of the voters drop out from the race. We throw in the new voter, the other person, and check if it's that particular person, and if their numbers are correct, then we would be able to return that particular person. All right. So return sorted. So this sort is going to take two items for x in A and B. This is our list, and nums.counts of x. This is our candidate, and we're going to return length of nums divided by 3, and that should work. It's a little slow because we went through 3 loops, but it's an O of n. Depending on a bigger, wider range of length of nums, we would have better results. Let me just make this a little bit more clear. So we're going to change the x to candidates. For candidate, the count of candidate. Perfect. So that's all. This is getting really long. I don't know how to make this less long. Can we do this? Yes, that works. Anything else would be I don't think there's any other explanation that needs to be made. If you have any questions, please put it in the comments below. And if you enjoyed the video, like, subscribe, and if you like to see more, look in the description below. You'll find my link to my website where I have iOS information that I'm working on and the algorithms that I've been doing. Well, thank you very much for watching, and have a good one.